Hi everyone, welcome to day 12 of Spark Learning. So today we are going to talk about data skewness. So yesterday we talked about partition, and partition will help you to improve the performance, how partition is helping to filter the data, right? Is partition works all the time, or is partition is the best way to improve the performance? So today I'm going to talk about a case where like partition may perform not in the perfect manner. So that is called data skewness. Suppose you have a column called category and you have the data filtered. You have the data partitioned. But imagine that like you have one category which is having like thousands of record, where like other categories have very less data. So in that case, when you create a partition based on a category, you will have a lot of data, and this partition take little longer to process, like when you filter the data or do the join. This particular partition would take more time than the other. So there would be a performance optimization issue because all other node completes the job but not this, right? So that scenario of like having an like even distribution on the data based on the data is called data skewness. As let us read the definition and see how data skewness is impacting your performance, and we'll talk about couple of solutions for that. So data skewness occur when partition in a distributed computer environment like Apache Spark are unevenly distributed, leading to a small same partition have more data than others. Some partition will have other data, as I said, right? This category is having more data but others doesn't have. This create a performance bottleneck because some tasks are significantly longer than the other, reducing the overall efficiency of the job. Correct? Hope that is clear. Like since the data is not equally distributed, your resources will not be efficiently used, and some of the resources will be overutilized, or like it might take more time, right? So how we will address the data skewness? So what is data skewness, right? I'll just summarize. It is because you have large amount of data on one partition. So the solution should be like splitting this data into multiple, right? Or reducing the reducing the shuffling, or like using the resources efficiently. We can think that way, right? The major problem is like one of your partition is overloaded, rest of them are not. So one way is like salting. So salting is like you will create a key on this column, then you divide your like the larger set of data into small chunks, and you create a partition for the key, like the newly created key column. So that technique is called salting. And we can repartition using any other columns, or like you can repartition just based on size of the data. So that way you will be able to reduce the overhead. But when you do that, you may have to compromise on the performance, given you may not be able to use that specific column into the partitioning, right? And adaptive query execution is something which is released in Spark 3. So here like system itself will takes care of the data, and it understand if there is a data skewness. It is going to partition the data internally and make sure that your resources are utilized efficiently. So we'll move on to the practical session, to the Databricks, and see how like whatever these three techniques which I talked about, how this is working. And also we'll deep dive into some internal how data are stored, and like what I told you in theory, right? Let us see in practical how the data skewness look like. Yeah, we are into our cloud community, Databricks community edition. I have this notebook open. So this is day 12. What are we talking about? Data skewness, right? So we have this heading, you know how to write this, right? We can use markup. So I have a small data set which I have created with three categories A, B, C, and I have values which I have looped it and tried to populate this data. Let me run this data. We can run this command by using this, and sorry, data skew dot so I think we don't need to do that because I already have the command here. So we'll run this much and see what we are seeing here. So I have total 90,000 records for the category A and 5,000 for category B and 5,000 for category C. So this by seeing this data, you know that 90% of your total record is A, right? And other 10% is distributed between B and C. So this part, now when you draw a deviation, right, you know that this is going to be the entire data is distributed in the area of A. So this process or this way of data distribution is called data skewness. What we did is we have just created this data frame and we grouped and took the count. Now what we are going to do, we are going to, so by default there should be a distribution, right? So we'll run this and see how this is partitioned, right? So this is partitioned into 8 partitions, and the data, this is so this command or this function will help you to get the number of records like you're seeing here, right? This is exactly same. So each partition, what is the number of records stored in each partition? Here what system did, it divided your 1 lakh record into 8 partitions from 0 to 7 and stored in this number. So here it is equally distributed. The reason why it is equally distributed, because we haven't taken any columns or anything. System took the entire count of record and divided it to 8 parts, right? So now what I'm going to do, I'm going to repartition this data skewed into 10 partitions using the column category, and we'll see how this data is distributed. I'm using the same command which will help you to get you how the data is distributed. Okay, so what's the result? Okay, it's here. So now you can see you have this data, however it is in category. So this is distributed like this, right? So okay, I think something wrong. No, df.skew. So it is distributed not in a right manner, right? However, you have 10 partitions here. Most of the partition does not have data, right? Because you only have 2 or 3 categories. So that is the reason. So now what this process of being partition, now the system is going to access each partition, right? The node which is going to access this data is going to take a lot of time to process your data, unlike others will not have any activity. So one way, if your goal is to repartition this correctly, you can directly give the repartition without column name, which will repartition based on the data sets. You will get some partitions like this. You can set the number of partition. So that is the one way, but at that time you don't get the benefit of this category column, right? Because if you are using the filter for category column, you wanted to get the benefit of category, but when you are partitioning without a column, you don't get that benefit. So now repartitioning does not work if I wanted to get the benefit of a column, right? So what should I do? Correct? So that is where salting coming into picture. So what is salting? So in a simplest manner, what I would say, salting is creating a new column, right? That column will have an additional numbering system where it will help you to split your data into different categories. Before we apply any partitions or anything, we are going to see how this data is distributed, right? So now I'm adding some of the SQL function where which I'll be using here. Now let us see. I think I already have this salt.show, right? So we'll run this. I can run everything, right? So we'll see how this salt look like, right? So we had these columns A, right? This category column. Yeah. So here in df.salted we already add a column called salt, that is this column. So what we did a numbering for this salt column, right? And we combine that number with the category. So now you can see that a underscore 3 is there, a underscore 3 is here again, right? So now if you take I think I'll show you how the salting is creating the new result, right? I'm going to do a group by on top of this. On which column? Salted column. Group by on this salted category, which will help you to tell me how this data is distributed. Now you can see so the AA category had a lot of records, right? Now you can see A7, so that number has reduced drastically. Like it was 90,000, it would be divided around like 9, so that is why you are getting around 8,000 9,000 record everywhere, right? It is splitted. So this is giving you an equal distributed. Now your data is not really skewed, right? It is equally distributed. Now what we are going to do, so what is this? It has to run here. We'll see that how this. Now you can see this distribution has changed, right? It is on. It is on. So which? Okay, I think I have repartitioned this. My bad. So what we need to do now, we need to do a partition for this salted column that is going to help you to get the data distributed accordingly. Let us see that. Yeah, so now what I have done is like I have you repartitioned my data based on the salted category. So what you have technically did, right? If you keep it in a very simplest terms, like you had a data where like it was like all the data, most 90% of your data was in one category. So now you used a method to split that data into a couple of chunks, maybe I'll say 10 groups, and you group that name by creating an additional column. So that gives you a parity to divide all your data in a similar size. Okay, so now you know that, okay, your new column salted category is helping you to like distribute your data equally. So this will help you to process your data, so that like now all your data have almost similar size, right? You can see this number, they are like most of them are in the similar size. So which is helping you to, if I give even better partition and numbering and everything, I would have got it even better. So here most of them are still in the same range, right? So it is helping you to like distribute the data perfectly, right? That is the method with salting. So keep it in mind, you are creating an additional column and like using a logic to have a random numbering and combining that number and creating a column, right? Creating an additional column and using that additional column to like create your partition. So that is what you are doing here in a manual method, right? Numsalt is like number of like times you are going to like split, right? Yeah. So now let us come into this method of AQE or like or adaptive query execution, right? So this is a method system itself is going to understand. Okay, you have a data skewness, so I need to act on this data when I'm doing my join operations. I need to act on this data and split them into a number of pieces, then like make this query faster. So you can enable that, like adaptive query execution. Like I have enabled it, and I have used the skew join enabled, so that help you to do the join. So I'm not going deep dive into that. Understand like these methods. Even like we can at some extent, in some places you might be able to use broadcast, which help you to improve the performance in some cases of skewness, because you broadcast, so you will get the entire smaller data into that particular partition. It also might help. So people say that, but in our specific cases, I thought like all of you already know what is broadcasting. So using broadcasting, salting, or repartitioning, all these methods take place when you understand your data and see where this really plays a role, right? So I want you to go back, analyze, okay, I have a data skewness. Is it really impacting my performance, right? Is that distribution is causing the issue? So you need to understand that, and you have to apply the appropriate method to improve the performance. But data skewness is one key challenge, so you can use group by or anything to understand if that exists, and you can take upon a required action. So keep this in mind. When you say that you did the right partition, still your query is taking more than expected, data skewness can be a reason. So here adaptive query is enabled, and like how you will know your adaptive query is working, right? When you go to our physical plan, you know what is explained, right? Execution plan. So here when you see this adaptive spark plan, right, this says that okay, system is taking care of your data skewness and acting. So I have another query which I used by disabling that. If you take it false, this is not going to use that adaptive method. In that case, you can see execution plan is referring anything, sorry, is not referring, come down. So it's not referring anything, it is taking the project. So here if you see our its project, it is mentioned like it is adaptive spark plan, right? So that is how you would be able to understand, did my enabling worked, or is it using the adaptive plan. So this hope this gave you an idea about what is data skewness, and what are the methods, and do we so you like in reality data skewness give you an overhead of like applying salting, or and you using a different partition to like use the resources. You often need to take a decision between resource utilization versus partitioning for the column which you need to use when data skewness coming into picture. Hope this clarify what is data skewness, and different approaches which we can take to improve the performance, and resolve the data skewness in your data set. Yeah, thank you for watching. We'll see you on the next video. Thank you.